I'd like to introduce Crista Shopis from SynacuseCoE. She is the president and co-founder of the business, senior engineer and department manager at Taitem Engineering, significant experience in mechanical engineering and in energy studies. She led the team that built and tested the, and I love this, prototype split airstream desiccant air conditioner. Say that twice. Assembling much of the unit herself. She's also delivered 2 prize-winning presentations at business plan competitions in New York State. The entrepreneurial spirit is alive. 2009, she was designated one of the 40 under 40 outstanding young engineers by Consulting Specifying Engineering magazine. So I appreciate that for reminding me how old I am. She has a BS in Civil and Environmental Engineering from Cornell, and she's going to tell us about her company's technology. So please welcome Krista.
Hi. This is exciting. Thank you so much for having me here today to talk about SynacuseCoE and to learn about Daitem and to see the artwork. So everybody knows, buildings use like 40% of the energy, and all the energy that buildings are using are creating this carbon catastrophe, and we think it's related to maybe global warming, and it's all very disturbing. So we're all trying to figure out, how do we reduce this energy? Companies everywhere, manufacturers everywhere, are striving to make these incremental improvements in energy efficiency with boilers, heat pumps, with traditional equipment, to bring down the load on the grid so we don't have to build it larger, to bring down the carbon in the atmosphere. I missed one. There we go. So, part of this problem is air conditioning. So air conditioning is 2 things, right? Just like you talked about, it's cooling the air, but it's also dehumidifying the air, and that dehumidification process is what's really difficult. Cooling the air is easy. You just pass it over something cooler than it, it's going to cool down. But in order to pull the humidity out of the air, you need to pass it over something that's 45 degrees. Now, 45 degrees is really cold. And Willis Carrier was sort of brilliant 100 years ago figuring out how we can do this, creating the vapor compression cycle, right? And so that 45 degrees is like the magic number in air conditioning right now. So how can we do this, right? Well, just like Brian was talking about, there's the Earth, right? The Earth is like this constant temperature, and how can we use it? It's cool in the summer, it's warm in the winter, and how can we use it? That free source of, we'll call it cool. I hate that word, but Ian kind of made it up. Ian Shapiro, Taitem Engineering, the inventor behind our technology, made up this word cool. There's this free source of cool right on the ground. How can we get to it? And geothermal technology is coming along. It's been around for a long time. I know that there's funding through Department of Defense to figure out better, cheaper ways to be digging these wells. So there's definitely movement happening. More wells being dug, more innovation around digging those wells. So maybe there's a solution here, but there's still that problem, the ground isn't 45 degrees. You want to get 45 degrees, you have to go really deep into Onondaga Lake or really deep into Cayuga Lake, hundreds of feet. So how can we get a temperature cool enough to dehumidify? Then Ian had a big idea. I should back up a little bit. My name is Crista Shopis. I am a senior engineer at Taitem Engineering, and I work with Ian Shapiro, the owner of Taitem Engineering, and the inventor behind this idea. And while at Taitem, Ian had this idea, right, to try to figure out how to accomplish cooling and dehumidification by using the source of the ground. And he had this idea, if we split the air, split the airstream, and heat one of those airstreams up, then pass the 2 airstreams through a desiccant wheel, the heated, dehumidified airstream dew point will rise above the temperature of the ground. Right? Not sure what this is. This was my site chart. Maybe we're not going to see it.
We'll
Something
imagine.
happened and my sight chart is gone. Okay, that's all right. We're going to go to this one. Okay, so what we do here, we'll do it in a slower motion, okay? This idea is very simple, by the way. Everyone who hears it ends up telling me, that's brilliant, it's so simple. We take the return air from the building and we divide it into two airstreams, okay? A large airstream and a really small airstream. There's a sweet spot in that balance, okay? And this tiny airstream, we heat up, okay? You can use any source of heat, and it's a mild source of heat, it's 160 degrees. Then we pass both airstreams through a desiccant wheel, and in this schematic, they're going in the same direction, but in a desiccant wheel, they have to go counterflow, right? We transfer all the moisture into that heated airstream. Now we've got this small, heated, and really saturated airstream whose dew point has changed. So now we pass both airstreams over cooling coils, which are fed with groundwater, a groundwater loop, 60-degree groundwater, okay? Because this airstream was so heated and saturated, when it passes over that 60-degree cooling coil, the humidity falls right out and goes down the drain. Now we have 60-degree dry air we can send back to the building. So there are traditional desiccant dehumidifying systems, and the difference here is they use outdoor air for this airstream. And outdoor air is already very humid. Okay, so we're using indoor air, which starts out already very dry. This is one area why we're more efficient than traditional desiccant system. So stop me at any time if you have a question about this process, because this is the simple point I want you to get. In the good graces of NYSERDA and the Syracuse Center of Excellence and grants that we won from both of them, we were able to take this idea, study it in the office, and then build a prototype and study it in the lab, prove the concept works, and prove that it actually worked better than we predicted, and we were able to achieve a patent, a US-issued patent, on this idea of splitting an airstream and using the indoor air to regenerate the desiccant wheel. So this system, this cycle of air conditioning, is patented, and that patent is owned by Synair. Here's a lovely picture of our nutty professor, Ian Shapiro, and our first ever prototype, which we built with the help of Syracuse Center of Excellence TAD grant. We tested that unit here at Syracuse University in the bees lab, and had a wonderful graduate student working on testing it for us so we could get some third-party verification on efficiency. Like I said, out of the box, it performed better than we had expected. We had predicted a COP of around like I want to say it was like 1.2, okay, because we thought it would be twice as efficient as a traditional absorption technology, which is around 0.6. Okay, we're a heat-fired technology, that's why we're comparing to absorption. Well, out of the box, we achieved a 1.8 COP. And that's using, those calculations are using the data from the lab, where we were using a chiller to simulate groundwater, and an electric heater to simulate a free source of heat. So of course, when we use this, we have our best efficiencies if we have a free source of heat. But, I'm sorry, we used a boiler. We started with electric, but actually, when Ian turned on the electric heaters, he blew up the unit. So we actually had to go back in and retrofit it with a hot water coil and buy a boiler and run it with a boiler. And actually, I was mistaken earlier. We used the cost of the boiler BTUs in our COP calculation. So that was a 1.8 COP figuring on needing to pay for that heat. So when you hook it up to solar heat or waste heat, that COP just drives straight up. You following me? Am I doing okay? All right. So what did we want to do with this? We had run out of grant money. We We were very excited, we had this idea, we proved the concept, we built a prototype, we got more funding, and we installed this in the Taitem Engineering building, and then it air conditioned our building for a couple of summers, and we took data, and it was actually performing even better than it performed in the lab, because you have all these days in real life where you need cooling but not dehumidifying. So on those days, our COP just drove even higher. And we thought to ourselves, what can we do with this? We're really excited about this technology. Well, Ian decided, it's kind of too busy running Taitem Engineering right now. It's a 30-person consulting firm. We're doing energy audits all over the state. We're going in on big proposals. We're helping NYSERDA run their multifamily performance contract. And he said, Krista, you help build this thing. Let's form a company and see if we can commercialize this unit. So that's what we decided to do. We formed SynacuseCoE just a year and a half ago. This January will be 2 years. We said, what we're going to try to do? We think we have a company here. We're going to try to raise some money. We're going to go see about those investors because we've gotten a lot of grant interest, and the people who give the grants are really excited about us. But there comes a time when the people who give the grants want to see, some money come out of the industry or the community. So we said, we're going to go after some investment money. We've got a compelling story. We've got an innovative product. It's patented. There's a market for it. Carbon story is really big right now. We think we can sell it. So we went out and made a push first for getting some investor money where we had to come up with grass like weeds, right? Investors want to know, how big is the market? And so we dove into trying to figure out, well, how big is the market? Here's the HVAC market. How much of that are we going to go after? Well, we decided we focus on buildings that have waste heat, that are a free source of heat. That tends to be like manufacturing buildings, industrial buildings, right? We've had some interest from people with those buildings in our technology. So we're really excited to focus on that technology. But we were also getting inquiries from office buildings that are going for LEED certification, or certain warehouse buildings we're talking about, educational facilities. Anyone right now that has a focus on carbon neutrality or for their marketing purposes. Nike, for example, has a huge commitment to their carbon story. And so they've got to dehumidify all these warehouses all over the state, all over the states. People like these are very interested right now in not burning fossil fuels, bringing down their carbon story. So this is where we told investors we're going to focus. It's about $6.5 billion, and we felt like we're on the right road because we had that word that starts with the B that they're all looking for. And we have a pretty great value prop. We thought, working in our industry, we keep all our numbers really conservative, being engineers that we are. And we're showing we've got great operating costs, very high installed costs, but when you look at the payback, our paybacks are still compelling. Our operating costs, you can see, just is so much lower that compared to conventional cooling, it'll pay back in 14 years, okay? That's without any incentives for digging any geothermal wells or anything. Geothermal heat pumps will pay back about 18 years, but you get government incentives for those wells, and payback drops a little further. So compared to heat pumps, we're looking pretty good, we think. And compared to absorption chillers, we're looking pretty good at 4-year payback to absorption chillers. So we're saying, it's not the 2 to 3 year payback, right, that Brian was talking about, which is the Grand Slam home run, but it's compelling. We felt it was a compelling story. This is the story we're going to tell our investors. The second part of the value of our unit, what's so brilliant about our unit, is inside the split airstream desiccant unit, there's only 2 moving parts, okay? There's the supply fan, and then there's a fractional horsepower motor. That's it. That's all you need to service. The desiccant wheel, the manufacturers of the desiccant wheel inside say every 10 years you'll need to replace your wheel. That is a cost, but it pales in comparison to the cost of the unit as a whole. Whereas traditional technology, you've got your compressor with all these specialty parts and pieces. You've got your refrigerant lines that are under great pressure and eventually crack and leak that refrigerant into the atmosphere. You've got fans, you've got motors. So you've got service calls, right? So we thought another piece of our value is, well, we've got two moving parts. We can sell that to the user. And here we're talking about, showing that we know our competitors. Oh, we know our competitors. We've got Taitem up there, a Carrier, of course, York, Vanix. And this was really something that the investors focused in on. It wasn't the fact that we had this great IP, this great idea, this incredible new piece of technology that's not going to contribute to carbon in the atmosphere. It's going to bring down energy demand, on the grid. Our product is like a quarter of the demand of a typical air conditioner. So everybody knows that whole demand story, right? With the grid, it's like we got to keep the grid, we got to keep the power plants big to be able to supply that burst of energy when everyone turns on their air conditioner in the summer, so we don't get that blackout. Well, these units have use a quarter of the demand. So, if we could get a significant number of these installed, we wouldn't be having that problem. But what the investors decided to focus on was like, wow, those are really big guys. Those are really big guys, and how does the little guy, compete with a big guy? And these are the same big guys that have been around forever. It doesn't change that much. So our greatest risk factor, all new companies have risk. The greatest risk for us was that we're so little, and how will we compete? And this is, from my standpoint at SyracuseCoE, where we are today, this is our biggest hurdle right now. Is how do we either compete or integrate or become interesting to, or somehow work our way into a giant industry that's full of really huge players that have been there for a really long time. Well, we said initially we're a little pie-eyed in the sky, and we said, oh, we'll just do just what they did. We'll sell our units through equipment reps to building owners, just like they do. It's no problem building, the equipment reps will do all the work, and they'll just call us up and order units, and we'll just sell them units. Probably not what's going to happen. Probably, and I have spoken with a lot of equipment reps. I spoke with Dan Bronson, and he's just fantastic. He's given me so much information on how equipment reps work out in the world. Ultimately, it would take a huge marketing effort, I think, for this to end up happening. But more realistically, where we're headed now is thinking of who can we partner with, right? In order to do something like this, in order for these people to sell to these people, your name has to have a reputation. And so in order to have a reputation, you need to be around for a long time. You need to have people using your equipment. So since we don't have that yet, we're thinking, who can we align with? Who has a reputation? Maybe they don't make the same equipment we make, but it makes complementary equipment. Who can we align ourselves with that could stand next to us and serve as our sort of reputation? And those people already have a whole distribution network. They have clients. They have repeat clients. So now we're thinking more of potential strategic partnerships and potential licensing agreements. But again, it's hard. We're a new startup company, and every startup company gets to this point where I think they call it the Valley of Death or something really inspirational like that. I'm a new entrepreneur. I'm learning those new terms. And that's where we are. And you can't tell on this chart that it's a Valley of Death, but that's what it is. We've done all this really wonderful R&D development, and we've gotten the product so far. We're not to commercialization yet, and we're not to sales yet, but we're run out of our grant money, and it's time for us to find other money, and that's this big chasm, right? This big valley you have to cross, where you have milestones to meet, but no money yet to meet them with. And that's where SyracuseCoE stands today, and that's where that's where right now we need to be innovating. We need to be thinking strategically and come up with new ideas about how to bridge that gap. That traditional means of going out and getting investor money, it's not so easy. clean tech over the last 10 years has kind of been hit hard a little bit with investments, and those investments not paying out. People are getting a little bit nervous and worried, and where I'm seeing investors going, and I go to a lot of these startup things, so I see a lot of new companies, and I watched who the investors go and talk to. A lot of them are going to talk to, of course, the building management software developers, right? Because it's software. You pay in your money, and that supports the salaries of some people who are writing code, and they write their code, and in 2 years you have something like the building management software equivalent of Facebook, and everyone's really happy because it made them a ton of money. And they make their return on their investment like they need to, and it happens in 2 to 3 years, and that's the business as usual. Most investors don't like our timeline because it's long. But we're building big pieces of equipment. We're not building software. So it takes a long time to build equipment. It takes a long time to test it in a real environment, especially if it's seasonal equipment. And people don't like that. It's not that hockey stick graph that everybody's looking for. It's a different graph. And in today's day and age, it may not be the graph that everyone's embracing, but we have to figure out as a society what to do about that, because what's sustainable about solely investing in software? How are we going to make investing in manufacturing sustainable? So these are the questions now that my team is thinking about. How can we be creative here? What can we do? So talking about my team a lot today. Here's my team. I've worked with Ian Shapiro, of course, the president of Taitem Engineering. Spent 7 years at Carrier designing and inventing heat pumps. He holds 9 patents. He's president of Taitem. I also work with Adam Conderman. He's an MBA out of Cornell. And Charles Hamilton, also an MBA out of Cornell. Charles is our business mind. He started and grew Novomer, another company in New York to 25 employees. They raised like $14 million. He personally closed on $6 million of it. He's been teaching me all these words like valley of death and luckily we have the support and help of Taitem Engineering, which is 30 consulting engineers, boots on the ground. They work with equipment representatives all the time. They talk to building owners all the time, and so we have their support and their minds helping us out. And we've also been extremely lucky to work with Air Innovations, thank you, Mike, in the latest design of our second generation unit, which is a 5-ton air conditioner. Our prototype we had built was a 1.5-ton air conditioner. This new unit that we're aiming to commercialize is a 5-ton air conditioner. And Air Innovations was just integral in helping us optimize on the design of our unit and improving the physical size to capacity ratio, and improving the fan dynamics. None of us knew anything really about fans when we built our prototype, and so Air Innovations was instrumental in helping us optimize on the fan and the flow of the airflow through the unit. So we've been extremely lucky to be working with them on our second generation design. And this was the pitch we went out and we made to investors. Hey, we just want $350,000 today to get through these next milestones, and then next year we'll need a 3 million round so that we can burst out into a manufacturing line with a contract manufacturer and start making sales. But that results. There was a lot of hurdles, like I said. Right now our hurdles are something that Brian talked about, first cost. That first cost to customer, as you saw in my earlier slide, we have a higher first cost. That's because if you need geothermal water and you need a source of free heat like solar or waste heat, that takes infrastructure. That infrastructure is expensive right now. So even though over the lifetime of your building you're only going to spend a quarter in operating costs, that first cost is a big deterrent today. So that's a tough one to overcome. Trust is a tough one to overcome with the customer. Like I said, we don't have a reputation yet, so they can't really trust us. Finding a demonstration site for our next unit has been hard. We need to find the right fit. We're getting a lot of inquiries for specialty dehumidification, but nothing yet that's been quite right with the cooling, the right capacity of cooling and a supply of waste heat. So we're looking for the right customer there. And tough with our hurdles with our business model. The value chain is difficult to penetrate. Big players, sedentary market, market's huge. It's a slow ramp up with, and I love this. This is feedback I actually got from an investor. Slow ramp up with unexciting margins. They want those 2 to 3 year margins. They don't want to see 7 to 10 years. It's like unacceptable. Long sales cycle. This is just true in our industry. You start selling an air conditioner at the design stage of a building. Design can take 6 to 8 months. Then there's the process of finding a contractor can take a couple months. Then they're signing contracts, getting started in construction, and the HVAC equipment doesn't get in the building until the building's mostly built. That could be a 2-year process before that product actually gets bought. So it's a very long sales cycle. And how can we reach customers more effectively than existing established players? Again, it's another area for innovation, and can my team come up with innovations there? And so that's just the state of a startup in the HVAC world right now. We're pivoting our focus away from specifically just looking for investment money, but now we're talking to a few people about potential license agreements and potential partnerships, and hopefully that is a way that new technology, truly innovative technology, can break into this industry that's been using the same technology for the last 100 years. Thank you.
Okay, please take a moment to think of your question. We'll remain silent.
Yeah, in your schematic diagram, you're talking about the return air. Is there any ventilation air, like outside air introduced?
Yes, you could add ventilation air into it, yes.
Okay.
Yeah, it would be into the return duct before it went through the unit.
And the COP will still remain like 1.2 you're talking about?
Yeah, I expect it would remain above 1.2. It would be more like 1.8 or higher, depending on the conditions, the environmental conditions at the time. So it depends on if there's a call for dehumidification. It depends on, if you have your free source of heat at the time, or if you're relying on your boiler at the time. So that COP is going to swing from like 1.8 to infinite. It'll swing around in there. It'll average somewhere higher than 1.
If you completed your A round and got you $3 million, where would you be? What would you have completed at that point?
What would we have completed at that point? We would be at a third generation unit that has intelligent controls that are backnet compatible, and we would have a partner that would be secured to contract manufacture them. We would have built 10 or 15 jobs, including engineers. We would be innovating on new HVAC technologies, and we'd have somewhat of a sales team.
So you'd have a revenue stream and profit at that point, or not?
At the close of the A round, no. No, it would. I think it would take. My most optimistic predictions would be 5 years to break even. But I'm an engineer, so I might be being conservative. But I don't think I think it would take 5 years to break even.
There was a moment in there when I was envisioning 3 Shark Tank guys. Fine, for this present, but actually, Ed, you have a question?
First, I want to thank Krista really for sharing with candor and grace your story. And this is like, this young child is like crawling around in the room, and we're getting to watch the development of the company. So really, thanks very much. I wonder about really specialty niche markets where the product could do something like no other product could do. So I was like trying to brainstorm, like, what about a nuclear-powered submarine?
That's fantastic idea. You know, I was just talking to Ian about cruise ships recently, but I didn't think nuclear powered
So
submarines.
we have waste heat,
How many
and
of
we have
those
like
are
seawater,
Yeah.
and there's people in a box, and you gotta like dehumidify.
Absolutely.
So, you know, if there are customers that, like, if you solve a problem.
It's the
they're-
same, information, it's the same idea that Mike's dad, Larry, sat with me at lunch, and just, the whole lunch, he just kept saying, what about this niche, what about that niche, what about the other niche, and it's where we need to go, it's where my team needs to just sit and think, you know, each week we need to come up with like a list of 5 niches, and who do we know connected to those, and how do we, and then we have to unfortunately tweak our spreadsheet every time to give us, you know, our results for that.
So it's reminiscent of, there's this small company, came out of Cornell, the microchip, right? So this is a product that harvests vibrations in the environment to create electricity. And the idea of the original was that we're going to put it in buildings for sense wireless controls, and, you know, sense the vibrations. But then they found this niche specialty market of powering tire pressure gauges. Tire is rotating, you need a battery in there, it's like, this is, and that's become their go-to-market strategy. So it's like, we need somebody, this is Norm's thing, we need somebody to give us revenue so that we can make product and then make more product for other applications. But what's that first market?
Actually, it was a comment on that. One of the Navy's electric ship program is really looking at decentralized heating and cooling and power generation systems. So I think that's great. Not just to nuke this up with the entire fleet going forward.
The Navy.
Yeah.
I might have a few connections.
Please. Would there be any benefit if you didn't want to invest in geothermal, to maybe still have a more traditional refrigerant but a smaller system?
Yeah, you know, that's a great question. We've been looking at hybrid solutions. You know, if you have a chiller already that produces 45-degree water, well, if you ran it in tandem with our system, it could produce 60-degree water, right? And so you're saving energy there. There's definitely a savings there. And if someone were forward-thinking and wanted to do that, they would have savings right away. We are really excited about the zero refrigerant story. You know, I read in the New York Times or the Washington Post this summer that by like 2050, 25% of the carbon in the atmosphere will be due to leaked refrigerant. 25%. That just blew my mind. You know, the refrigerant, we all know it's getting greener, right? It's no longer got, there's the global warming potential, and then there's the greenhouse, the ozone depletion, right? So we're not getting any of that ozone depletion anymore. But boy, we're still high on the global warming potentials. So that's a real problem. So we get really excited about this idea about zero refrigerant. But you know, we don't want to let that get in our way. You know, Ian continually tells me to build it as a 4-pipe fan coil. That's what it is. It's a 4-pipe fan coil. You send it warm and cool, and we make air conditioning. And I like that idea too. The investors didn't like that idea. They don't really.
We have time for one more. There's a hand.
I'm kind of on the same path, but instead of the chiller, how about running a conventional refrigeration cycle but at higher temperature?
Yeah. Yeah.
So you have a hotter source, and the cold side is also hotter.
Mm-hmm. Right. Yes.
And we could use some organic fluids that are not so bad for the environment.
Yeah. Yes. And that would be a way to bring down first cost. And so it changes the value prop a little bit, but it brings down. But on the plus side, it brings down that first cost, and it will make it more, because the unit itself is not expensive, so it would make it, you know, competitive on the first cost. And I have to run numbers to see if it's, you know, how much of energy you're saving while running that vapor compression system also.
Okay.
It's definitely somewhere to look.
Thank you.